The only thing you need to do to assemble these items for your activity are to take one of the foam balls and one of the planets with a golf tee attached and insert that golf tee into the foam ball. Now this represents a star with a planet, and the golf tee represents gravity holding the planet to the star. The other thing you need to do is to take a little tiny chunk of the clay and put it on the end of the toothpick. That represents the Earth-sized planet. And put that into one of the other balls. The third ball is the star without a planet.
Welcome everyone. Today we're going to be talking about how we find planets around other stars. For the longest time, all we knew about was 9 planets around our own sun. But now we have discovered more than 100 other planets, but they're not around our sun. They're not planets in our solar system, they're planets around other stars. So what we're going to do today is talk about just how we find these things. I mean, the planets around our sun, you can look up in the night sky and see a bunch of them. Not quite all of them, but a bunch of them. So to find these other planets is a bit trickier. The stars are all so far away that we've never seen one of these planets. All we see is their effect on the star that they're going around. This is a model of our sun. See if you can spin that. Oh, very nice. The sun spins just like that, just rotating like the Earth does. But there's something wrong. This sun is kind of naked looking. Is our sun up there all by itself in space?
No.
No? What does it have?
Planets around it.
Planets. So with these 2 stars, I have some different kinds of planets. Let's see how this planet affects the spinning of the star. This is going to be a little bit trickier. See if you can get that one spinning well. Woohoo! Give it another try. All right. Very nice. Now when you watch that moving, was it a nice simple spin like this? No? How else was it moving? What would you call it?
Up and down.
Up and down and...
Just all around.
It was wobbling all over the place, wasn't it?
Yes, it was.
That wobble is what we look for when we look for planets. Because the other planets, the stars are so bright that we can't even see them. At least not with the telescopes we have today. The planets are so tiny, they don't shine with their own light. They're just reflecting a little bit of the starlight and they get lost in the brightness of that star. But that planet's doing things to this star. It's making it wobble. But that wobble is so tiny that if we want to try to find smaller planets, let's take a look at this one. There you go. How's that spin? Was it like this one or this one?
It was more like that one and this like...
Yeah. If it's just, what's the difference between these 2?
This one's bigger and that one's smaller.
That's right. If you have just a tiny little planet, you don't get much of a wobble at all. If you have a nice big planet, you get a big wobble happening. And so far, the only planets that we found have been big guys like this. We haven't found any little ones like Earth using this wobble method. But if we can get our telescopes up in space and we can get sharper images of these things to see them moving, then we hope that we can eventually start to find some of these little guys. Because it's a finer motion, it's a tiny little wobble, and the atmosphere tends to blur things out. So if we can get above the air, we can see the tiny little wobbles that little planets like this make. Now there's 2 other things that we can do. I'm going to talk to the adults who are up a little bit higher now. And I want you to watch this planet go around the star. Imagine this was glowing, okay, giving off its own light. This is not. This is only reflecting the light of the star. As it moves around, your eyes are about the same height as mine now. What do you see when this happens?
It's almost like an eclipse.
You're right. When it's a small thing like this, we call it a transit. An eclipse is when the entire star would be covered up by the planet. But when it's just making a little black dot across, it's called a transit. So if we're measuring the brightness of a star, we'll see a little dip. It'll seem to get dimmer and then come back up. Do you think we'll ever be able to see the planet directly?
No.
You don't think so? Well, we haven't so far, but NASA's got a plan. They have a mission that they're designing now called the Terrestrial Planet Finder that will actually block out the light of the star so you can see this dim, tiny little planet off to the side. And then we'll be able to confirm that there's other little planets out there and be able to see them directly and make measurements of the light reflecting off them to find out lots more about what kind of planet that is. But that's in the future. So far we don't have anything like that, but they're working on it because they would like to be able to see the planets directly. Thank you.
Here's two stars. What's the difference between these two stars?
One has a planet and one doesn't.
One has a planet and one doesn't, you bet. If we take this star and spin it, you see the pattern that it makes? Now how about this one?
Wobbles.
Yeah, you see that wobble? It's detecting that wobble is how we find these other stars that have planets around them.